Okay. The next construction material is structural steel. See, whenever I was talking about the RCC or PSC, I was using the naming as reinforcing bars, reinforcing steel. So, what is this steel actually? What kind of steel we can use in the construction activity and how they are available, how we can utilize them for the different purposes. Let us have a small discussion over that. So, basically the steel which we are using in the construction, it is of two types. One is for the called as the high tensile steel and another one is the uh, stainless steel. See, majority of the stainless steel what we are using in the construction activity, it is only for the decorative purpose, like might be for preparing the hand grills for the staircases or any other decorative or architectural views, we use the stainless steel. But the major steel what we use in the construction activity is high strength steel bars. See, these steel bars, they are available in the different forms. So, this steel is available in the form of steel rods, steel bars what we call them as, or it is available in the form of wires or cables, which I was mentioning in the pre-stressed concrete. We use it for the tensioning purpose, or also instead of RCC or PSC, if you are constructing steel structures, there also we are using this steel in the forms of angles, channels or I section, T sections. So, many in the many different forms we are using the this steel in the construction activity. So, as I mentioned, the types of steel which is available in the market. So, the first category is bars, like the straight bars. So, these straight bars either may be square in the nature or they may be circular in the nature. So, these square bars usually we use for the construction of the interior works, like for the window grills or might be for the staircase grills or maybe any other barriers. So, we use these square bars for the construction of the interior or decorative items, whereas majority of the times the circular bars we use it for the reinforcing purpose in the concrete, either it may be in the uh, um, RCC or it may be in the PSC. The circular bars what is available in the market, we use those circular bars majority time for the reinforcing purpose. See, if you again concentrate more on the circular bars, so these circular bars, there are many different category of available, that is FE415, so FE500, then FE550, like this different grades of the high yield strength bars are available. So, we use all these for the reinforcing purpose. So, whereas these square bars, it is usually used for the interior decorative and they will be mild in the nature. So, we call them as mild steel bars. And the steel wires and cables, which is basically or majorly used in the PSC member. So, the member which we are using in the PSC or the steels, they will be of high strength, like these wires or cables, they will be somewhere around FE 1200 grade. So, 1200, that is the yield strength of these steel bars which we use using in the PSC members, they have the higher yield strength, that is 1200 newtons per millimeter square as their yield strength. And if we are going for these steel structures, what is steel structures? Steel structure basically it comprises of all the structural members made of steel only, like column is of a steel member, beams it is a steel member, like that. So, either it may be like that or might be here seen the trusses. So, trusses whenever there is a requirement of large span, we go for the trusses. So, trusses they are basically made from the steel sections, either they may be of angles, channels, pipes, tubes Like that, many different sections are available in the market, and majority of the times these steel sections, there will be of Fe 250. It is a mild steel sections we will be using. Now, why we need to use these steels for the construction purpose? What is the uses or advantages we need to see? What are the advantages? The major advantage of use in the concrete, it is having a very good high tensile stresses, or it is a very good in resisting the tensile stresses. That is a major advantage of the steel. And the second advantage is the thermal expansion coefficient of the steel and concrete, it is almost the same. So, it does not affect the temperature. Even means, it means there is a variation in the temperature, both concrete and steel, they will expand and contract to a same amount. So, there will no differences in the expansion and contractions. And this steel is a good workable material. What is meant by good workable material? That is the bending, cutting, welding, joining. So, it is very easy in case of steel, whereas RCC we cannot cut easily, we cannot bend them, we cannot weld them. It is not possible in case of RCC, whereas in case of steel it is very easy. The steel, as it is an elastic material, it has a very good elasticity, and also it has a very good ductile properties. So, the elongation and contraction of the steel alone, it is good. And depending upon the requirement, we can temper the steel material. So, if you need a very hard material, so we can convert it from mild steel to hard, we can convert it very easily. And the steel can be treated chemically if required. See, after the continuous use of the steel for the construction activity, might be they get corroded, and we can treat it very easily, or we can repair them. We can reuse the steel in the construction activity. The reusability of the steel is also very good. Means after using the some steel for the construction for 10 years and 20 years, even we can reuse the same steel for the next construction also. Now, let us see some of the major use of steel material in the construction activity. Now, if I come to the RCC construction, in the RCC construction we use this steel bars majorly as a reinforcing bars. That is one major activity. And in case of steel constructions, all the steel construction activity, like either it may be a column, beams, or any other materials, they will be made of these steel members only. So, in case of RCC we use the bars, whereas in case of steel construction activities or steel buildings, we use I section, channel section, tube section, pipe sections, then angles, such kind of sections we use in case of RCC. And in case of PSC constructions, we do not use the bars or we do not use the different sections. Here, in case of PSC, we use the wires or cables for the tensioning purpose. Either PSC, it may be a post-tensioning member or it may be a pre-tensioning member. In both the situations, we use wires or cables, right. So, this is something basics or some brief information about the steel which we use in the construction, right. Okay. Now, we will see the different construction chemicals which nowadays we are using in the construction activity. See, as the technology is improving, so we have got many different chemicals which we are using in the construction for the different purposes. For example, now I am using some ready mix concrete for the construction activity. Let us assume that the ready mix plant is somewhere in the nearby city. and the construction activity which is happening, it is far away from the city area. So, the ready mix which I need in the site, it need to be brought from the city, right. So, as we all know that concrete has the setting times. So, it starts hardening after initial setting times like 30 minutes or 40 minutes, and it has a final setting time like 600 minutes, or that is 10 hours, right. But the time I need to bring the ready mix concrete from ready mix plant to the site, let us say it is roughly around 45 minutes. So, if I bring the ready mix from the plant to the factory, by the time it reaches the construction site, it has already started setting. So, I cannot use that concrete for the concreting purpose. Then what I have to do? Then we have to make use of such chemicals or the chemicals which is available in the market, which retards or accelerates, which changes the properties of the concrete, or I cannot say which delays the setting time or which enhances the initial setting time. Though it will not affect the strength of the concrete, only what it will do, it will the setting of the concrete will get delayed. So, instead of setting the concrete in 30 minutes, it will go for 40, 45 or 50 minutes as per our requirements. So, like that there are many different chemicals are available in the market, which we are using in the construction activity for different purposes. Now, let us see few here. The first chemical what we are using is polymer bond agent. So, it is a polymer based bonding material to enhance the bonding in the concrete. Either it may be a brick bonding, or it may be a stone bonding, or it may be the bonding of the aggregates in the concrete. So, to enhance the bonding between the materials, we are using some of the chemicals which we call as the polymer bonding agent. So, by use of this polymer agents, the bonding between the material will be automatically get enhanced. In turn, it is giving us a good strength. Basically, so this is a strength enhancing agents. The second one is mold releasing agent. See, whenever we are constructing some of the structural members like footings, beams, columns, slab, so we need to go for the framework. So this framework, if you don't apply any coatings, what they will do? They will get attached or they will get bonded with the concrete. Means after the casting of the concrete, we cannot be able to remove them. So, if you want to remove them easily, then we have to use some of the mold releasing agents. So, after creating the fabrications or after going for the shuttering, what we have to do? We have to apply these mold releasing agents. What they will do? They will not allow the framework to get attached, to get bonded with the concrete. So, that is a second kind of chemical what we use in the construction activity. Now, the third one is concrete floored hardeners. So, see, whenever there is a necessity of to set the concrete very fast. For example, you have casted the concrete road where the movement of the vehicle is very frequent. So, we cannot leave that road to block, so that the concrete get hard for the 10 hours, like that we cannot block the road. So, in that situation what we need to do? We need to use some of the chemicals. What they will do? They will speed up the hardening process. Instead of hardening the concrete in 10 hours, it will take around 2 hours or 3 hours and it will set for the final. So, the hardness or the strengthening process will go faster. So, it is an accelerating chemical. It will enhance us, it will increase the hardening process. Like that there are many different chemicals are available. Now, surface retarders. So, this is another kind of chemical which we use in the concreting purpose, especially whenever there is a joining. See, for example, if I am casting a big slab today, and I know that the casting of the entire slab is not possible in one day. So in that situation what we do, so we start casting the slab from one end, and wherever for the end of one day, so wherever the junction or wherever the joint is possible, so at that joint what we will do, we use this retarding chemical. What it will do, it will slow down the process of hardening. It will not get set in one day. So the concrete will remain fresh even after some 12 hours or 13 hours, so that we can continue the casting of the slab in the next day also. So it will not become a joint. Or else what happens, so if you cast one portion of the slab today and if you cast the next portion of the slab tomorrow, so that joint it will be having a joint, or that portion where we are attaching two slabs, it will become a joint, and always these joints will create a problems, leakage problems. So to avoid that, so we can use the surface retarders which will reduce the slowdown of the strengthening process. Next, bond aid for plastering. So as the name indicates, this is a chemical which we use in the plastering purpose for the bonding. So whenever if the surfaces are very smooth, like if you have a wall and to that you want to do the plastering, if the surface is very smooth, then the smooth surfaces it is very difficult for the plastering, because plastering will not be attached to the walls. So during that situation what we have, we can use this bond aid plastering, where if you use this bond aid, it is easily attached, or it is easily we can do the plastering to the smooth walls. Now ready mix plaster, so it is not a chemical basically, it is a ready made available material where all the mixtures for the plastering is available in a packet. So you can just open it and do the plastering, no need to prepare the mortar for the plastering purpose. And the next one is waterproofing chemical. Nowadays this waterproofing chemical has become most common and everyone know what is this waterproofing chemical. So whenever there is a leakage either from the floors or either from the water tanks, so we use this waterproofing chemical to avoid the percolation of the water from one end to other end of the concrete work. So nowadays whenever there is a heavy rain in our locality, we have seen that our houses will start damping. There is a small percolation of the water from the slabs or might be from the walls. So it is a usual scenario everyone face in their day-to-day life. Especially this is a situation where we observe during the rainy seasons. So during that, if you see any dampingness or the percolation of the water, then we can have this waterproofing chemical which is wrapped around. It has to be done on the outside and inside as well, as so that we can avoid the percolation of the or movement of the water from outside to inside. The next material is adhesive. So it is, we know that either for the carpentering work or might be for the interior works, so we need the adhesive. So this is an adhesive, it is basically used to attach the wood. Then the next one is the rebar coating. So rebar, it is a steel material, it is an iron material. The chances of getting corrosion to the rebar, it is very common in the RCC, because we know that we are reinforcing this steel bars into the concrete. Concrete has the water, so getting corroded of these steel bars is a very common in RCC. To avoid that corrosion, what we have to do is we have to use this rebar coating chemical which is applied over the reinforcing bars before reinforcing into the concrete, so that it will avoid the corrosion of the steel bars in the concrete. It is not that a popular chemical because the cost is little bit higher, so usually people don't use this in the last one is epoxy coating. See, whenever there is a crack filling or the filling of the joints, especially in maybe in the flooring work or tiling works, So, we can use this epoxy growing material to avoid the seepages of the water. So, like this there are many other chemicals are also available in the market which we use for the different construction purposes, right. Okay. Hello everyone. Today I am going to take up with a new topic, that is the structural elements of a building. The topic is structural elements of a building, right. So, here in this topic we will be dealing with what are the different types of the structural elements in a building, and there is what is the purpose of that element, or what is the function of that element we will be discussing. So, before moving that, you can see these structures basically they have classified into two things. One is called as the superstructure, and another one is called as the substructure. So, what is this superstructure and what is the substructure? It's very simple. The structure or the building, or can I say any construction activity which happens above the ground level. So, all those construction activity or all those construction we call it as the superstructure, and vice versa the construction activity which happens below the ground level, it is called as the substructure. In a simple ways I can say foundation, you can see the foundation it will be below the ground level, so it is a substructures, whereas you can see the column, walls, slabs, beams, they all are above the ground level, hence they are called as the superstructures, right. Now, if I go with the different types or the different elements of the superstructure, the first element which will come with the foundation, right. So, what is foundation? Foundation, it is a structure which supports or which holds, withstands the entire superstructure on it. The foundation it may be of any different types. You can see in the structures we have different types of foundations, like it may be an isolated footing, or it may be a stab footing, or it may be a stab footing, it may be a combined footing. There are many different types of foundations are available in the field. The basic function of the foundation or a footing, it is to transfer the superstructure load to the ground or to the subsoil. That is the basic function of the foundation, where it is transferring all the loads, that is load from the superstructure, that is load from slab, load from walls, beams, column, all these loads will be transferred to the soil through the foundation. So, that is the function of the foundation. Then after the foundation, the next structural element what we have in the building is the plinth. So, we call it as the plinth beam nowadays. So, what is this plinth beam? After the foundation, when we comes to the ground level, and at a ground level we supposed to construct the walls. To construct the walls, we need a solid structure. We need a solid structure, the solid component on which we can easily construct the walls. So, above the ground level, or at the exactly at the ground level, we have a solid structure which we call as the plinth, which will act as a base to the construction of the walls. Usually this plinth, it is constructed at the ground level. So, neither it is above the ground, or usually it is not the below the ground, it is exactly on at the ground level. So, neither I can say that it is a superstructure nor it is a substructure, as it is exactly on the ground level. Then the next structural component, it is the lintel. See, walls are not the structural elements. So, in the framed structures, walls are treated as the non-structural elements, as they are not taking or they are not transferring any of the loads. So, walls are treated as the non-structural elements. Okay. Now, what is the lintel? So, lintel, it is the structure usually constructed at the door levels, you can say. Usually around at the 7 feet we construct a lintels which connects the column to columns. So, why this lintel is required basically? See, whenever we have openings in the doors, the openings it may be a door openings or it may be a window opening. So, whenever we are providing the openings in the walls, so above that opening, constructing wall is a very difficult task. So, to construct walls above these openings, we need again a solid structures. So, these solid structures, it is usually a lintel work. So, lintel work is nothing but it is basically an RCC beam, which is usually of the smaller thickness. So, this lintel, it is constructed over the openings. Now, if we provide some projection to these lintels over the openings, so the depending upon where we are providing the projections, so they have some different meaning. That is, the next structural component is chhajja. Chhajja is nothing but basically the projection of the lintels above the openings. See, what we do, whenever we provide openings for the purpose of either it may be a window or maybe for a purpose of doors. So, during the rainy seasons or during the sunny times, there is a chance of entering water into the houses or in the buildings through these openings, or maybe chances of entering the too much sunlight in the building through these openings. To avoid the entering of the rain or the sunlight from the door openings and window openings, what we do to protect these openings, we project the lintels beyond the walls. So, these projections, they are called as the chhajja projections. Sometimes what we do, we project these lintels inside the building. The projection of the lintels outside the building, we call them as the chhajja. We call them as the sunshade. If we project these lintels inside the building, so we can the function will remain same, but we can utilize them to store the goods and all those things. So, it is a multi-purpose projection, that is chhajja. Okay. So, usually the lintel and chhajja, they are of the RCC components. Then the next one is the columns. So, columns in any framed structure, so again one of the most important structural element which transfer the entire load from the slab and beams to the foundation. From there it will go to the soil. So, the structural engineer is the one who is going to decide what should be the sizes of the columns and beams and how much reinforcement we need to provide. So, columns usually they are slender in the nature. So, the dimensions will be very small compared to the walls and all those things. So, usually of like 9 inches by 12 inches or 9 inches by 15 inches depending upon the loads and the type of the structure. So, the column is basically it is a vertical member which transfers the load from the beam and slab to the foundation. So, in an RCC structure, the RCC column will be the major thing, right? So usually you can see these columns, if you have visited any apartments and the parking area, you can see the columns and how they are arranged and all those things, right? The next structural component is sixth one, it is beams. So beam is a horizontal structural member. So usually the beams are provided over the or it connects the column to columns and it carries or it holds the entire slab. So the beam is also called as the flexural member because the bending moments in the beams will be very high, or the beam is critical for the flexural loads. So which undergoes the transverse deflection and it takes the loads from slab and it transferred it to the columns. So it is a horizontal member. Basically the function of the beam is to hold the slab, right? Then the next one is it is slab. Seventh one, the slab. So we all know what is slab. It is a horizontal member. The slabs are basically constructed to divide the building into the different floors. The basic function of the floor is to provide an additional space in the building where we can occupy that space for the different purposes. So if we just keep on constructing the columns, then it will becomes only one building. If you divide that the entire height of the column into the different floors, then the same building can be used for the different purposes, or you can say we can have the more area to do the different jobs. So whenever we go for the construction of the slab, or whenever we divide have the multi-story structures, to climb the different floors in any building, we need a structure which is basically called as the staircase. Staircase is the structure. It is used to climb the structure, or from one floor to another, either to climb, step up or step down. We need a structure called as staircase. So it is one of the important structure in the building, because during the any emergency time, basically we need to use the staircases in the apartments or in the multi-story structure. So apart from all these different components, even we have one more thing, as I mentioned, that is walls. As I said, walls is basically, it's not a structural member if it is a framed structure. That is, if we are providing footings, columns, beams and slab, that is basically called as a framed structure. So in the framed structure, we don't treat walls as a structural component, but there are some construction activities, some of the buildings where we don't go for the framed structure, that is, we don't provide the columns and beams. The slab is casted directly over the walls. So in such circumstances, the walls will be transferring the load of slab to the foundation. So under those situations, the walls will be treated as the structural elements. So walls, they may be of a brick construction, or they may be a stone construction activity, or nowadays we have the new different elements, like we have the cement blocks or ACC blocks, many other hollow blocks and all other things are there. So we can construct anything, but basically if walls are transferring the loads from superstructure or loads from slab to the foundation, then the walls are treated as the structural element. If not, then the walls will be a non-structural element in the buildings. Okay. So, these are the some of the basic elements in the building.